you trust Ferguson Roof Systems to replace your roof, we go the extra mile to protect your home and property. On every job, we deploy durable netting to protect your home's exterior and landscaping. It's just one more reason why you should call Ferguson Roof Systems today.
Hey everyone, Meteorologist here in Tuttle with you. Make sure everything's good there. A little something goofy on my end. Hey, thanks for tuning in here this evening. Hope you got some sleep. Some of you didn't get any sleep at all, depending on where you lived here around the metro. Some of you obviously got a lot more. It kind of depended where you were in relation to the tornadoes that we had across the area last night. I've been really busy today, so I didn't have a whole lot of time to kind of look back to see what all happened, how many tornadoes occurred, all that. I just know that I was exhausted. So I've come on here. I really wasn't even going to do a live tonight. And then I looked at the model data trend for Thursday, and I thought, oh boy. So we're going to talk about potential tornadoes again coming up for Thursday afternoon. So that's why we're on tonight. So make sure you like and share this video. Hit the old share button as we speak. You might get some people to tune in right before bed, which is probably not what they want to hear, just to get a good night's sleep. Come to think of it, they probably don't want to hear this at all. But it is what it is, and we got to talk about it. So anyway, thanks for joining me out there on Facebook and also on Rumble. Guys, for checking in. YouTube, as usual, the crowd's in the house. Always thanks to see you. Uh-oh, here from Mustang. No damage, just no power for 3.5 hours. Jim, good to hear. I know you were kind of close to that tornado that did move through that part of the town. Guys on Twitter, also thanks for checking in, and of course on Facebook. And let me post the link like I always do. If you're having trouble getting notified when I go live, I will post your opt-in option, so you can click on this. A few hundred of you do this just about ever so often. That way you don't miss a live broadcast. If you're getting the notifications, you don't need to do it. It's just the ones that are missing stuff for whatever reason. Hey, Debbie sent me some stars. You know what that tells me? That tells me that Facebook fixed their stars problem. All right, so if you guys have been watching tonight, you tried to send me some stars the last few nights and didn't work, try it now, see if it works, because Debbie's just got through. So Facebook must have finally fixed something. It only took them a week. That's pretty good. But anyway, all right, tell you what, let's take a look at the conditions out there currently. 56 degrees, so not bad. Temperatures out there today were pretty decent. I kind of like the weather. I see Tiffany. All right, so it looks like it's working, so I appreciate that. But like I said, we've got some other things to talk about here. And let me pop up today's high temperatures, because I just want to see how nice it was. Just kind of just a good thing to have, after an event like last night. All right, so here's a look at the temperatures here for today. And that's what I'm talking about, man. 70s out there. Abigail, I see you. LaDonna, I see you. Thank you. So yeah, man, 70s. Woo! Now that's nice. We do have a little bit of a cool spell coming our way, but then it's a short-lived one, and we'll be right back in the action. And the action, unfortunately, is this kind of action. So this is the preliminary outlook for the Storm Prediction Center. Thank you, Sasha. So we've got the... Let me turn on my little pointer here. All right. There we go. So right now, the Storm Prediction Center is highlighting this area right around the Dallas-Fort Worth area, southeast Oklahoma, kind of more concentrated here. However, this, of course, is based off of older data, and as you know, sometimes things shift around and move. So we're going to look forward, see if we can get an area of low pressure here across central Oklahoma, and from that point forward, we'll see where the dry line sets up, and if we have to pull everything back a little bit, into, for example, Oklahoma City metro area. So we're going to look at here for tonight. We're going to show you everything why. All right, you guys are awesome tonight, coming in, Summer and Micah, Dana, Carl. So I really appreciate that. All right, so let's go to the... First off, let's take a look at the upper levels atmosphere, 500 millibar pattern. See our energy, our vorticity, our lift in the atmosphere. Jody, I see you. Let's see. Let's go. This is the American. This is going to be a snapshot in time for Thursday afternoon. So the position of this low is going to vary. This particular model has it here. This is the Canadian model, has it here. The American model has it here. The NAM model has it here. The other Canadian model has it here, the high-resolution version. And the UK Met has it here. Okay, so that's quite a difference in the position of the upper low. And believe it or not, this matters. two things matter. One is placement as in back to the west. The other is placement up here to the north. So if you get a more northward placement and one's a little bit back to the west, it slows down the timing, the progression, and it puts central Oklahoma back in the mix. So that's why all that is important. Now, regardless of where those models put the upper level low, the jet streak at 300 millibars is nicely defined across our region. So you have a split jet here and a split jet here. So again, evacuation of the air right over this region. Sharon, I see you. Thank you very much. For the stars. So that is the lift we need in the very upper levels of the atmosphere. Plus, looks like we got a little bit of wind with this one too. So that's the UK Met Canadian. Look at that wind. Oof, that's some big speeds, 150 knots. Here's the NAM model, the American model, and another Canadian, and the European model. So very similar look to all of them. So we got some upper level winds coming our way, which will help to create the storms. Now let's go down around 700 millibars, find the lift along what would be the dry line or a cold front or something to trigger at the surface. So the Canadian model's got it kind of focused in this area here. The American model's all over the place. There's really no rhyme or reason. The NAM model kind of keeps it more focused along this area. And then the other Canadian is kind of all in this area. All right, that's a big difference. All right, so there's really, what you're taking home right now, there's no cohesiveness yet in the model data. Thank you, Michelle. So you can take a look at the different models here for the instability. In other words, the cape and shear. So this is like 2,000 joules per kilogram, for example, here in North Texas. This is Dallas-Fort Worth. Again, we're caping a look at you guys down there in Dallas. So the instability has returned in this area for Thursday afternoon, kind of nudging in to southern Oklahoma. When you look at the Canadian models. All right. Now, if you look at the American model, it's kind of in line with what we saw on the Storm Prediction Center outlook, right? Which is kind of more along like this. And if you take a look at the new NAM that came in this evening, look where it is. Now, if you're asking me, well, Aaron, which one do you believe? Well, unfortunately, because I'm talking about it, I believe this one. So that's the NAM model. It's our first short-term version of these convective models, which usually has the better outlook on it than these other global, less sophisticated models when they're talking about storms like this that we're in tune for. So you can see this little triangle approach here in the wind field. This is over Shawnee. I'm just picking a random spot here just to show you what the forecasted parameter is should the NAM model verify. So the atmosphere is very saturated. That's where the red and the green come together, which is interesting. You usually don't get a saturated atmosphere that much. But what it also has is very significant cape values up around 2,000 plus, no cap at all. And it has a lot of speed shear. Bukus of speed shear, and yes, enough directional shear. Now, normally for tornadoes, I like more of a west-southwest component down here around the 850 to 700 millibar level, which we do not have. However, this is just a different view of the same atmosphere that can produce the same outcome. So the shear is still decent. It's over 264 on the surface for shear relative helicity, and a little higher than that once you go up a couple of kilometers. But possible hazard type, you see that right there? PDS tornado. In other words, it would entail a intense tornado in the EF3 to EF4 category right here on the analog chart when you factor in these numbers with hail sizes up to around baseballs. So all these little indices are off the chart along with wind damage. So 1.9 value on this. So 1.9 on the wind damage value. So in other words, this, if taken at face value, is a nasty afternoon or late afternoon and evening for parts of central and eastern Oklahoma should this verify. So that would mean tornadoes and significant and large tornadoes. Now, you know my rule. I like 48 hours for the cutoff. This is Thursday afternoon, so we're just outside of that. Again, so we'll see how the models trend. But right now, this is the way the NAM is trending. And we'll see if the other ones come in line. But that is not a pretty situation. That's why I got to bring it to your attention. So we take a look at the other ingredients like the moisture, the dew point values, right? So the European does have some 50s and 60s way down here in southeast Oklahoma, North Texas. If we look at the other models, you see there's the Canadian model there. Here's the American model, kind of to the east, southeast. Here's back to the NAM. It's got all the juice where it needs to be. So dry line setting up out here, more traditional of west central and southwest Oklahoma. The blend of the models kind of has it more anchored over here, which kind of jives with the Storm Prediction Center. And these other two kind of splitting the difference back a little closer. So we'll see what happens with the dew point values, but it looks like, again, the plenty of juice is there to tap into. When you look at temperatures, it's also a different story because we'll have a cold front that'll come in And I'll show you how that looks like here in a minute. But at that snapshot in time for Friday afternoon, depends on which model you believe. The European likes us to be on the cold side, into the 40s. Hey, that's not bad. I'll take the 40s. One of the Canadian models, the global version of it, kind of got a little warmer, the low 50s. The American, all right, well, going upper 50s, some low 60s down south. Kind of a similar outcome what we had on Sunday with the American model. Now the NAM says, no, we're going to be in the low to mid 60s here in central Oklahoma, and maybe even some 70s down here in southeast. If we look at another version of Canadian, right about 49, and the UK Met also 49. So most of the models keep us on the cold side. The NAM model, which usually is the better, or I should say maybe best model of all handling cold air, says the cold air is gone. So keep in mind, it was the NAM model did so well at forecasting this last event with those surface temperatures. Thank you, Angela. Thank you, Mary. Victoria, appreciate the stars, ladies. Let's see. So let's take a look now at the outcome. So what does all that look like? Well, the European has got a lot more thunderstorm activity by this time, and it's kind of centered across southeast Oklahoma, back down here into North Texas. So if we do some plot forecast soundings, kind of give you an idea. Let's do that here real quickly. So southeastern Oklahoma, marginal tornado is what it got on the forecast sounding, but all the other indices do indicate probably a likelihood of a tornado in that area. Although surface-based cap is probably a little strong, but I think that'll do the trick with all the lift. And then down here, like in North Texas, say like we'll just pick around the Tyler, Longview area, it has a PDS tor down there. So in other words, it's the same environment that we would have here if you believe the NAM, but just across the Red River. In other words, so the atmosphere is potent wherever it sets up. So it's either it sets up in northeast Texas, maybe far southeast Oklahoma, or it sets up back here in the Dallas-Fort Worth area, points north into central Oklahoma and southern Oklahoma. So that's the deal with the European. All right, now remember the NAM we talked about. It's got those thunderstorms right here in central Oklahoma. We already showed you a forecast sounding for that. Let's pick down here in Dallas, see what they look like. Again, potential forward tornado there, but with the NAM, a much stronger cap in place that may preclude development in that region. All right, so now let's go to the Canadian model. Canadian model, it's a weird look to it. Kind of has this frontal boundary still way down here, so severe weather risk in Oklahoma is pretty much non-existent. It maybe has a little bit of risk down here in northeast Texas, so let me just pick like Rockwall, for example, down here. And it has a marginal severe thunderstorm. So, like I said, it's an outlier as far as the look goes. And then finally, the American model. We'll take a look at that one. Similar kind of placement that the European does. Let's see what it does here for southeast Oklahoma, just for the look. Marginally severe, so it's not very impressive there. Northeastern Texas, so we'll go kind of close to the Tyler areas, a little east. Marginal tornado. Let's see here. Instability's there. Hail is there up to 3 inches diameter. So it's got some decent thunderstorms with that one. And of course, that extend on here it is. And you guys for southern and central Arkansas. All right, so that's kind of the take home of how the look is with these storms. And believe it or not, on the back end of this, we're going to have a little bit of snow. Depending on which one verifies as to what we're going to see in the form of the rain, cold, snow mixture. Tabitha, thank you very much. And Rustin, thank you. All right, so we look here at the NAM. It actually has some snow in Kansas and northern and northwestern Oklahoma. Canadian model kind of has some hit and miss light snowfall totals for the Panhandle, northwest and southwest Oklahoma. The American is just kind of a hit and miss hodgepodge of snowfall all over the place and across the state. And the European still also has some light snow out here northwest. So there you go. We're getting some snow somewhere. That I can tell you. It all depends on the track, and we probably won't know that really until tomorrow. But at least that's kind of how things are looking. And then finally, I promised you we'd take a look at those temperatures, right? So let's do this. Let's go back to this panel, and let's just assume that the NAM is what's up. It knows what's going on. So let's just go with that. And I will even go with its... we'll stick with this one. This ought to be good enough for what we're talking about. Okay, so let's go into Tuesday. So Tuesday, another nice day. We've got some 60s out there and 70s across the state for the afternoon high. So I like it, kind of like what today was. All right, let's go on into, let's see, does it show the cool down? It does. So Wednesday morning into the 40s and we're going to rebound you, though, into the lower 60s this time. It's not quite as warm, about 10-degree difference. So that cold front will make a little bit of a difference here for our Wednesday. But Wednesday morning, remember, we're on the cold side, which most models agree with, so we're in the 40s. However, what happens in the afternoon? Does that front retreat and mix out, kind of get a warm front action in here? And if so, we're back in the mid-60s to upper 60s here in central Oklahoma and 70s down in southeast. So our cool down is brief. Northern Oklahoma, though, still stays pretty chilly on Thursday into the 40s. And then finally, with that system moving through and out on Friday morning, if you look back behind it, there is some 30s coming in here, Panhandle the 20s. So yeah, maybe we'll have a little bit of snow mixed in parts of the state with that final hurrah as the storm moves off. And it's too early to show where that's going to be. We just know that right now it's a signal in the data. So temperatures as a result here in Oklahoma City, and your town will be similar until we have that front to deal with. So in the low 70s tomorrow and 60s on Wednesday. And then Thursday, the blend of the model is going about 61. Thank you, Kim. And then as we head into Friday and Saturday, a little cooler, especially in the morning. And it looks like we're going to squeeze out a pretty decent Sunday and Monday of next week. And we kind of have this little rock and rolling roller coaster ride. Now, I did not look again at the long-term data, but I did see there is a front coming in at this time frame. And it does look like a very large high-pressure center coming in across Canada, and looks like probably going to be a little bit mixture of either that Arctic air or continental polar air, one or the other. So our temperatures right here, don't believe these numbers, are probably much colder than this. Whether or not we get some winter precipitation on top of it, to be determined. I have spent zero time to look at it because, like I said, I'm still recovering from yesterday, as you probably are as well. All right, so that was everything I want to tell you. So bottom line is keep an eye out for Thursday afternoon here across central, southern, and southeastern Oklahoma for potential tornadoes once again, down into North Texas, including the Dallas-Fort Worth area and northeastern Texas. We'll get more accurate data to look at tomorrow, probably starting in the morning. We'll probably should have a good trend that the other models are starting to kind of congeal on. And then tomorrow afternoon, so that'll be Tuesday afternoon, so Wednesday, Thursday. Yeah, so that'll be 48 hours out from the event. Should be golden then. We can start narrowing down exact placement of where all that kind of stuff is going to be. I really wasn't ready for this. I don't know if you guys are ready for this, but I certainly wasn't. Oh, the other thing I wanted to show you, let me put this up here. So this is the tornado tracks that were being surveyed today by the National Weather Service. Thank you, Tania. So they did have that track that was around Mustang that worked its way into southwest Oklahoma City, and then kind of diminished once it got up around the Bethany area, kind of just southwest of 44 there. The other track was the one that went through between Minko and Tuttle, and then diminished up here almost to I-40 around the Canadian road. I forgot what road that was, east of Banner, I believe it was. And then down here in Norman, we had the one that formed. It started actually forming around Goldsby's where the circulation started, and it looks like it touched down right about the interstate, and then went, of course, on the north through Norman on the south side, southeast side, up to the north of Pink, and then finally diminished once it headed toward the Shawnee, toward, let's see, it was east of, well, it was out in the middle of nowhere. It was by the radar site for the 88D is when it started to kind of diminish. And then finally the last track was the one that kind of formed northwest of Shawnee near I-40. That crossed over and went up to the north. And there's another potential track after that that's over here in this area. But that will be discussed from the Weather Service in Tulsa. They'll take care of this one. But the one in Norman, they'll take care of these 5 here. It doesn't mean that there wasn't other tracks in the state. That's just what the Weather Service highlighted for today. I'm sure there were a few other tornadoes in the state, and it usually takes a survey to go out there to make sure. It can be time consuming. It can sometimes take them a week at most, but they try to get it done usually in about 48 hours, especially if there's another storm system coming. You know, it's kind of like we don't have time to waste, so we got to get at it. It can be more difficult, though, when you have like a straight line wind event, though, that kind of obscures. It makes it a little bit harder to find these exact tracks. But anyway, so that's kind of what they do there. Let me think. Anything else think that was it. I want to thank you guys for watching last night and telling your friends and family about the coverage. It's a completely different approach. I get that. Some people, actually, believe it or not, I hear this because I see some of the comments. Angela, that's hilarious. So some of the comments are that, and this is funny to me, he's too calm. Just like, what? He goes, yeah, this if I got a tornado coming, he's too calm. Like, it translates into it's not a big deal. And so I gotta have somebody just as worked up as me, and which is hilarious to me. I'm the complete opposite. I'd want somebody to calm me down if I'm all worked up. But some people, they want to get worked up. And if that's the case, yeah, I'm definitely not going to be your guy. I will not work you up. But yeah, it's when I see those type of comments, I get a chuckle. But anyway, so my goal is to calm you down, let you get the prefrontal cortex activated so you can think logically, make some smart decisions when it comes to protecting your life and your family and all that kind of stuff. And maybe even, text your grandparents or whatever. Let them know. Of course, they're probably watching TV. I know my grandparents watch TV 24/7. They used to tell you rot your brain, but they made it pretty far with a pretty decent brain. I don't know how they did it. My grandpa was 105, so he made it, and he was always got that TV on in the background. But anyway. All right, so let's see. That's about it. Let's see. Sharon, do you think this will be an active season since we're starting out this way? Well, the funny thing is we were supposed to have kind of a shortened season because winter hanging on with too many cold air intrusions to kind of keep the Gulf of Mexico shut down. But we keep getting these resurgence briefly between, which keeping it somewhat active around here. And then we had a La Nina, which was transitioning to an El Nino, and we're kind of in the springtime going through that. So as you go into summer, it's supposed to be much stronger El Nino that kicks in. Usually that means a wetter, more stormier pattern for us, and a milder pattern usually when it comes to like the winter. But again, long range forecast, I got to tell you, it's a grain of salt because it's a general trend, but there's a lot of little events that happen in that trend, which perception is reality. So you get like one huge cold blast, or you get one huge ice storm or snowstorm, and in your memory that was a bad winter. So but when it comes down to the numbers on page, we'll see how that goes. But I don't usually focus too much on all that stuff. I mean, it might be fun to talk about, but it's usually just a bunch of silliness. It's like the Farmer's Almanac. I don't put much effort in that one either. And there's some outfits that do. They try to forecast long term. I don't mean just like 6 months or 90 days. I'm talking about they try to do years out. And I'm like, come on, man. Who are you trying to fool? It's cute. But I will say this. I'm going to load this for you because I do want to show you this from last night. All right. So this had the weather community talking on Twitter, going nuts. All right. This is probably a record. Now, what happened was the guys in Norman, National Weather Service, decided to launch a weather balloon before the tornadic storm developed and moved into Norman. Now, it was, trust me, it was sheer luck, total coincidence. It's not like they knew it was going to form a tornado right there and then move right through that part of Norman. They did not know that. But the models, the short-term models, did indicate an enhanced area of better probability of a tornado in that area. And we did talk about that here. I showed you the maps live. So they, those kids thought, man, let's sample the atmosphere real quick, like a research, meteorologist, and we're out there on a project. And so they launched their balloon 15 minutes before the storm. Actually, it's a little longer than that, but by the time it finished the whole thing, it wasn't long. It was 15, 30 minutes before that storm arrived. And so it sampled the atmosphere it was coming into. And so the interesting thing is, one, this thing had the most strongest cap I think I've ever seen in a situation with a tornadic thunderstorm. Matter of fact, in theory, it shouldn't have happened. Honestly, if you had asked me in class, back in college, could this have happened? My answer is no. It's silly. Don't even think about it. Matter of fact, you couldn't get any storms in this environment, anything that was surface-based. So that was strike one. But the other thing, and this is maybe where We sometimes think we know it all until we find out something that we don't. So this is the other thing this thing shows. So we had a huge photograph that we talked about. It's nice big curvature and nice little wind field that goes from the southeast to the west as you go up with height. So we had nice, decent shear in the atmosphere, so we knew that. And we knew it'd be quite high. The models did forecast some pretty decent shear, but to actually sample the shear is a whole different animal. It's not a model forecast, it's actual reality. So surface to 1 kilometer was over 1,000 meters second per squared. This is storm relative helicity. Now, just so you know, to get a tornado, you only need like 200 or something. And we were over 1,000. We look at the surface to 3 kilometers, we were at 1,116. So this has never been sampled before. These numbers have never been seen in real life. And we got to see it last night in Norman right before the tornado hit through. So this is why all the meteorologists today were geeking out about this number. Now, that said, and I'm not the expert in this, but somebody's going to do a research paper and try to figure it out. So at some university, you're going to look at all the data and they're going to try to figure this out. And there's some theories going around. But I'll just throw out a theory too. On our axis that we give, so let me do this. So let's say you've got an axis like this, all right? And you've got Cape on this end, and you have shear, I'll just do an S for shear, on this end. All right, and it goes from low to high. And let's say up here is 1,000. All right, and down here is 0. And Cape over here, we'll just say this is like 2,000. We'll make it easy. So typically, on this graph, for tornadoes to occur, your Cape value has to be roughly about 1,000. That's what this point is, 1,000. All right, so that's usually about an average. You can get them down here about 500, but they like 1,000 to 2,000 and up for tornado development on the Cape side. On the shear side, as you go up, so this would be 500. 500 is kind of like almost an overkill. Like you really don't need 500. It'll work anywhere from about 250 to 500 in this round for tornadoes. So your sweet spot then between the two, you could say, is right about here. So on our little graph, if you have Cape of 1,000 and shear of close to 500, you've got yourself an environment of tornadoes. So what we do not usually have is an environment where we did have about 1,000 Cape. If you go most unstable, surface was only 500. So you're kind of in this zone here, really, in reality. You're closer to 500 in reality for surface base because, again, it was pretty stable that day. So surface base, it was mediocre. You can get a tornado, but it's really hard to do. But we're in the off the charts here. Like we've exceeded the chart. We can't. In other words, there's no numbers of 1,000 plus. So it may be, and this is just oversimplifying things. It may be we were able to get a tornado with this huge cap, just because we had shear that was so high, none of this other stuff mattered. And that is an example of how we think we know it all, and then we come back and we see something that goes, huh, didn't see that coming. So this is an example of how shear may be the ultimate deciding factor when it comes to tornadic thunderstorms versus instability, and specifically surface-based instability. So anyway, just want to throw out there because it was neat. It was little scientific stuff that happened last night as those storms moved in. Because remember, most of the storms weren't producing tornadoes, and they tried to. They did have warnings out on them, but they just really weren't producing that much. It was the one that went down around Norman, which was super strong on radar. It looked like probably an EF2, EF3 on the radar wind speed estimations. We won't know until the survey's completed, but that's just looking at the data. And those ones south and west of town were also pretty strong. But that one was kind of the outlier, and it came into this environment where it shouldn't even have been a tornado for because of just of the profile of the atmosphere. Anyway, that was just kind of neat. Just kind of geeking out there on that deal. Because I had actually shown earlier on Sunday a chart that compared some of the indices on where we're dealing with high shear environments. And because of that, you can end up with a violent tornado in those higher shear environments. And we actually add a higher shear environment. I was like, ooh. I said, here's the deal. This is weird. I mean, if we didn't have the lack of the surface instability, if that wasn't a key element, you would not have liked the outcome of Sunday. If you thought Norman was something, that would have been nothing. All right, that's how potent that atmosphere was. But because that cold air came in, it saved us, and so that was the deal. So to see even that type of a strong tornado happen when none of the other storms could do it, any other part of the state, but only at that spot at that time, that's pretty amazing stuff. But the good news is it happened, very close to radar coverage. So it was easily tracked. It was easily spotted, street level by street level. However, the other issue is with that is when they are moving at 50 to 70 miles per hour, the storm itself, tracking those things is very difficult. Meaning, and this is again another radar lesson for you. So what happens is on a radar, just so that you know, it's instantaneous, but only for that second. So let me put it to you another way. When a cop is out there with his radar gun, and you're bebopping along the highway, and he pulls that little trigger and goes zap, and they say he's using a laser gun. All right, zap, boom, he got you doing 85 and a 65. Now, in theory, you may have only been doing 85 for a split second, and he just happens to catch you at that split second. You're like, well, I wasn't going 85 the whole time. I was just, whatever. He got you, right? So the point is, that split second in time, that's an instant measurement. Beyond that, there's no other measurements. So in the weather radars, it goes around. It's on a pedestal that rotates. It hits the storm at that split second, and it moves around, comes back around, hits that storm again. Now the issue is the radar itself doesn't stay at one position. It does one tilt, two tilts, three tilts. In other words, it's going, let's do this. Let me grab my old trusty marker here. All right, so this is our little radar guy here. And this is our little pedestal. All right. This is our little, what I'm doing here. But like I'm in class. All right, so this is our little pedestal of the radar. And the dish sits on top, and it shoots out this beam like this. This is your beam of energy. And it goes all the way around, like this. Anyway, and as it does so, then it tilts up like this on the second one. And then it tilts up like this on the third one. And it tilts up on the fourth and the fifth and the sixth. And then it comes back down the surface, and it tilts around again. So we're tracking tornadoes. We're tracking the area closer down the surface. So once it tilts too high, guess what happens? We can't see the tornado anymore. And we have to wait for it to come back down. So we put these in what we call volume scans. In other words, we'll let it go around, all the way around, and we'll tilt up once, let it go all the way around again, and then we might let it go around one more time, and then we tilt it back down. And so we can sample the atmosphere again, and then go back up to where we left off, and keep going up, back down the bottom, etc. So the point is, in the old school days, we would let it go all the way up once, and then come down. So that whole process would take 6 minutes. So you could only sample that one spot, that one target, in that one part of the storm once every 6 minutes. That's not doing anybody any good when you're trying to track tornadoes, right? Because they usually happen in less time spans than that. So the solution was, okay, we'll split it in half. We'll go up 3, and then we'll come back down 1. And if they want to get real aggressive, they could go up 2 and come back down 1. Regardless, the most update you're going to have is probably going to be every 1 to 2 minutes. That's the minimum amount of time you can sample it. So again, if you have a storm moving at 70 miles an hour in 1 minute, right, it's already gone a full mile. So if I'm looking at a map with the radar data, and I'm pointing at this intersection right here, well, in reality, if a minute or 2 has already gone by off the clock, it's already jumped 2 intersections over before it has a chance to get sampled by the radar again. So that's what I'm saying. It's very difficult. In a slow-moving tornado, it's not that much of a problem. You get one that's moving around 25 miles per hour at most, that's fine. You can approximate and good. But if you got one hauling at 70 or 80 miles an hour, it's jumping, blocks quickly before we see it again on the radar. So that's the downfall when you're dealing with a tornado that's an environment like that that's moving really fast, and you're trying to give street-by-street direction. So in other words, what happens by the time I tell you where the tornado is on radar, it's already occurred. And we may be now, 30 seconds behind time in current time, and I need to be future time, right? So at that point, then, you're stuck with trying to predict where that tornado is going to cross the next intersection ahead of time. And not only 1 or 2 intersections, maybe 3 or 4. So you're thinking 2 or 3 miles down the road, and you're having to approximate in your mind, well, it's probably going to be here already. right? And this is all approximation and guesswork. So what you could do in that case, and I'll probably have to do this more next time should that occur, is the radar approximation to the last known location, which I did repeat a lot last night. Last known location was key because it was moving so fast we wouldn't know the current one. But I can look at the track line and then give you it's going to hit here and then here and then here and then here, and then you guys can obviously know you'll be in the direct path. Now that's assuming it maintains that straight line path, and over a period of a few miles, that's questionable. When we're trying to do street by street, we're talking down to a 30-meter point that I'm trying to pinpoint across an entire city. So we're trying to get really, really specific in an environment that doesn't really support that. So that was one issue last night that we had covering the storms. The other is, and this is what's frustrating for me, I know it's frustrating for you, and I'm going to tell you right now, and I talk about this to behind the scenes people, there is no win-win on a situation where you have tornadic storms in one part of the state and you have tornadic storms in the other part of the state. So like last night we had 3 tornado warnings up in northern Oklahoma, and we had 3 down here in south central Oklahoma, which included Oklahoma City Metro. There is no win here. In other words, I can try to cover each of these storms, but then I've got to leave those storms, go back and cover the ones up north. And when I do that, everybody down south is angry and upset. Wait a minute, is it coming from my house or not? Where are you going? And then the people up north are going, are you not going to talk about these tornadoes up here? Hello, aren't we people too? So I'm telling you, there is no win-win for me. So all I can do is as fast as I can, scan each one. And in that case, what I have to do is a judgment call. I go, based off the radar data, I go, not concerned, I'm not concerned. You're on a standard tornado warning, stay there, right? If you've got the warning, and you can't, and I'm not covering it, one of two things. One means there's too many others to cover, and there's some that actually have tornado indications on radar and or much stronger, is usually the main issue. So like last night, we know we had tornadoes in the central part of the state. We knew they were somewhat strong. We knew they were doing some damage due to debris balls. When I went to go look at the northern ones, they had tornado warnings on them. There were no debris balls, and I honestly couldn't guarantee there was even a tornado there. In that case, I'm not going to spend a lot of time on those. I'm going to go back down to the ones that I know are imminent to life and property. But I still have to leave those to go check on the ones up north. So I want to give you a little behind the scenes in my mind of what goes on during that situation so that you can understand, Amber, so you can understand what goes on and how I'm thinking about that stuff. At the same time, I'm looking at the data. At the same time, I'm trying to figure out what part of town am I in, where are my intersections. Let me get these to show up on the road so you can see where this thing is at. And then going back, remembering where these other storms were, to go back and look at those and do the same thing. So it is a mess. At the same time of that, I'm still scanning up, to see if anybody has any live shots, there's any actual proof, of what's happening, to get a visual look. And then I'm checking every now and over here with the National Weather Service to see if they're passing along any information. So it is a production. Now, I'm 49 years old. The brain still works good enough to do all this. Now, when I'm 69, it probably won't. I'm just throwing that out there. I don't know. Maybe it's enough. But at some point, there's going to be some level of diminishing returns in what I'm demanding for this thing to do up here. So I got to stay healthy. I got to eat. I got to exercise. I got to take my vitamins. Just got to say my prayers. And then hopefully I can go as long as I can doing this. But I can just tell you a little bit of the complexity that goes on behind the scenes when all this is happening. At the same time, I have to talk to you and be calm, cool, and collected, and then remind myself to remind you how to seek shelter, when to seek shelter, that kind of stuff. So there's so many moving parts when you're doing the storm coverage for a tornado event. And it complicates things when you're a one-man band. When I was in the news stations, I didn't have all that responsibility all at once. In other words, I had I'm going to watch this tornado here, and then that's it. But I would have people talking to my ear. We have so-and-so who has storm damage. We have, so-and-so, the Weather Service just did this. We have, so somebody would always be in my ear telling me something else that I then could relay. I wouldn't have to be the one that physically went and looked at it and then processed it and then told you while I was still talking and everything else. So there's a lot more help in the TV world on the news channels when that happens. You got your live shots from your helicopters, and it's a break, right? And then you can go see that for a little bit, and then you come back to the radar. So it kind of breaks things up a little bit. So it is a production, whether you're watching the guys on television from 4, 5, and 9, for example. Even 20. I saw 25 was on the air last night. I was like, hey, where'd you guys come from? But yeah, 25 was on the air. But yeah, so whether you're watching those guys or you're watching me, same kind of deal. Now, I can't speak on their behalf as far as what they think or what they do. I'm in a different situation just because I have more access directly to the internet. So I can find things and look for things on the fly. I have special tools that they don't have for radar detecting things. So I've got a lot more tools at my disposal that I can talk you through that are a little bit more technical, that if you're on television doesn't quite work out so well. You don't really have that format to do so. And I'm also in control of everything that's happening. So I'm in control of the flow. Whereas, say, for example, if I was at the station, I got so-and-so in the Weather Center wants to talk, so-and-so in the news desk wants to talk, and I'm being told where we're going and directed versus me knowing where we're going and directing. It's a little different. But that's a whole different animal. I did that for 12 years. Now I'm doing this for, where are we? 23. So, whoa. You know what? That's almost 9 years. I started doing this in 2014 for broadcasting severe weather coverage. So I'm at year 9 of that going in. Pretty good. So we'll do year 10 by the time this is set up and we're hitting 2024. How about that? All right. Anyway, so that was just a little side note of kind of what happens. I know you guys are on the other end just wondering, is it going to hit my house or not? And so that's all you got to worry about, whereas I got to worry about everything else and however many hundreds of thousands of people's lives, right, I've got in my hands, and I take that seriously. So I got to be on my game. Anyway, so hopefully there wasn't too many injuries. I think there was a death in Cheyenne. Like I said, I wasn't online today to see what all the totals were, so hopefully it wasn't too bad. Always sad when that does happen. And most tornadoes are small. EF 0, EF 1. So again, if you're new here and you're watching, you're from California or whatever, you're like, what did I come into? That is not a normal daily thing around here, just so you know. That does not happen that often. And when they do happen, they're usually pretty weak. So, and they're like needles in a haystack, and they're usually out in the middle of open areas. Matter of fact, last night, if you recall, I was toggling off the radar. That's another thing that I do that you can't do on the TV stations. I'll toggle off where the radar is so we can look underneath it, and then we can see, oh, it's over literally fields with trees and there's nothing there, or bushes or creeks or rivers. So if I were to come out there and go, oh my gosh, we have a tornado right here, we have a tornado, it's 4 miles west of so-and-so, we got to take cover. And you go and you look, and the only thing out there is a cow and a bush. You tell me where the proper handling of that is. Is it the clown show hype Armageddon, anxiety building, hype train, or is it the, oh, phew, it's all right, it's out there in the middle of nowhere, it's fine, let it be there. So I'm on that secondary mindset versus the first. I've been in the first business for long enough to where I didn't want to have to put up with that anymore, so I don't have to, so that's good. It's always good to be your own boss. That's for sure. All right, so anyway, so I got it. Oh yeah, Chris, is it really going to snow Thursday night? Yeah, there's some snow in the outcome on many of the models. Right now they kind of favor northwest and southwest Oklahoma for a little bit of a dusting of snow. Can you explain a pivot point and a squall line? Mike Lee. I'm not sure what you mean by pivot point. So usually when you're talking about squall line, if you'll talk about anything, it's the bow echo. And the bow is where that forms damaging winds that come in from a process that captures the winds aloft in the mid-levels of the atmosphere, and they transfer down the surface in the form of straight line winds. And if you don't have a huge cap involved, like we did last night, you could get what you call like a derecho, which is a nasty squall line that's like 200, 300, 400 miles long, and it's got damaging wind all the way up and down the line. There was some talk that we were going to have that, I think, for Sunday from some outlets. I don't know. I just heard it. I don't know who said it. So I don't know if it was the government that said it. I don't know if it was, TV people. I don't know if it was storm chasers. You got me. I don't know. Somebody shared something with me. I was like, no, that ain't gonna happen, because we didn't have the atmosphere for that type of an outcome. It was too capped, so not enough instability. So that was one of the issues that prevented that. Let's see. Are you gonna be at the Severe Weather Expo next weekend? Yes. So that is in March. Let me look at my calendar here. Oh, is that this week? March 4th. Oh, I didn't even do a blog yesterday. Oh, I forgot. There was too much going on. There's not enough for me to go around. Ugh. I meant to do that. I knew there was something I was forgetting, but I was so swamped with too much stuff. Yeah, because I gotta promote that, man. So yeah, next Saturday, I'll be at Penn Square Mall. God, it came up fast. So I'll be out there live with the TV stations and some emergency management, weather service at Penn Square Mall from 12 to 3. We're going to be in the lower foyer in the middle of the mall, a little big area. And it's a big deal. So a lot of people come out and they will stand in line. Carrie, you're hilarious. They'll stand in line, get autographs, and they'll meet the guys on TV and whatever. So I've been out there with them the last few years. Of course, we had to take a little 2-year break hiatus because of COVID, and then we're back at it. So yeah, I'll be out there. So thanks for the reminder. I just pulled up my Google Calendar. I was like, oh yeah, that is this weekend. I need to get on that. I need to be cloned. I need to be cloned. That's my solution. If I can clone myself, I'm good. That's all I got to figure out how to do. All right, listen. I tried to get out of here about 20 minutes ago, so we're gonna do it for real this time. It is 10:35. I get ready for bed, man. Some of us have to work in the morning. All right, listen. You guys have been good again. Thanks for checking in tonight. Thanks for your comments and the stars. By the way, it looks like Facebook finally fixed it. By the way, you guys on YouTube also that have sent me some super chats. That's awesome. So I appreciate you there. Sorry I can't always answer all the questions, and I know from the comments though that the few that I do see, you guys bounce around everywhere, and so I know you watch all the guys and you compare and you contrast, and it's funny. I mean, you guys are severely avid weather fans. Let's see. Channel 9 claims no delay with their radar, and they're the only station in Oklahoma City with it. True as far as you know, John Wakefield on YouTube. Okay, so all right, so I'll address the radar situation, and then I'm really gone out of here. So when I told you that the radar has a program where it goes, here, that's on the National Weather Service radar. So I was speaking on behalf of the NextRad system. TV stations, some of them do have their radars, their own radars. Now I will tell you this, they do not do the tilt system. So they just do the one level scans. They don't have to wait and come back down. In that case, depending on the rotation rate of the radar, all right, how long it takes to go around, depends on how fast that is. It can be anywhere from 10 seconds to a minute. A lot of the engineers want to save wear and tear on the radar, so they slow it down. When I was at Channel 5, and I had them put in a radar upgrade, and I tweaked it to a Maserati. I had it to where we had a radar scan that went around every 10 seconds, and it sampled tornado strength up to an EF5. In other words, you could actually see the wind speeds unfolded in real time. That would show, if you pixel queried them on the air, it would show up to 200, something miles per hour on the air. And I thought, man, if I was ever covering severe weather and we get an F5 on there, I'm pixel querying. I'm going to show you these wind speeds on the air. It's going to blow everybody away. So I tweaked the radar to do that. The engineer didn't like that, so he kept making it go back slower. And some other things. So I can't speak now on what mode they use. But if you can watch that little, the little thing that goes around, so if you watch that go around, you can count, how many seconds it takes to go from one point to the second point. As long as they're not using a fake sweep and it's a real sweep, you'll be able to see how long it takes to go from one point back to the other. So no, they're not the only radar that can go at a faster rate. And as far as no delay goes, that's just an old marketing trick. What they mean is when they compare to the National Weather Service, they call it a delay. So in the old days, the radar trick for the TV stations was to say, we don't have a 6-minute delay. In other words, that's how long it took the Weather Service at the time for their radar to show an update was 6 minutes. So they can say, we don't have that 6-minute delay. You know, we're instant or whatever. And you're instant, like I said earlier, for that one time that cop has you in his radar gun for the laser and he zaps you. After that, you're no more instant, just like a storm is no more instant. You got to wait till the thing comes back around. So it just depends on how long they take. But the problem also is when you do those scans that fast, 10 seconds, the data quality suffers unless you're really close in. And I mean close in like within about 25 miles of the radar. If once you get out beyond that distance and you run the radar too fast, you lose too much data, and then it becomes more smeared and it's smudged together. It doesn't look as good. Quality's not as good, so it's not really usable. It's visual. I mean, you can brag about it, but it's not really usable for data. So there's a trade-off in how fast you spin that thing. So you got to find that happy medium. Like when I had my F5 mode at Channel 5 that I created, and we could do it in 10 seconds. It's because I tweaked it so that the energy is focused only on about a 20, I think it was about a 25, it may have been 30, but somewhere right around there, mile radius from the radar, which doesn't cover the whole Oklahoma City metro area, but a good chunk of it, so that if there was something that came in there, I could flip that over to that mode and we could just get rapid updates, which is pretty neat. So anyway, it's a little more behind the scenes stuff, so I'm filled with information, useful or non, or otherwise. Okay, for real, I'm out now. Ron, thank you for the stars, by the way. Appreciate it. And the goat, the goat icon. All right, so yeah, John, it would have been a big deal. It would have been more like a big May 3rd event, I'm sure, had we not had the Arctic front in here. So, be thankful that we did. Okay. See you guys later. Have a good night. I will check in with you tomorrow, and we'll see how Thursday looks going forward. All right. Take care. Good night.